A person cannot be in two places at once, regardless of speed, because humans have mass. Traveling at or faster than the speed of light is physically impossible. Even at theoretical speeds, atoms can only exist at one specific coordinate in spacetime at any given moment. The fundamental rules governing this include the mass barrier. According to Einstein's theory of relativity, objects with mass require infinite energy to reach the speed of light, c. No double location, moving faster than light, if it were possible, would result in a paradox, causality violations. You would never occupy two distinct coordinate points simultaneously. Rather, you would arrive before you left from the perspective of some observers. Time dilation. As you approach the speed of light, time for you slows down significantly relative to a stationary observer, but you remain strictly localized in a single place at any given instant. If you'd like to explore this, I can explain how time dilation changes the perception of time near the speed of light. The concept of quantum superposition, where particles, not people, can exist in multiple states. The physics behind why faster-than-light travel creates time paradoxes.
Relativity theory does not assert that a person or object can hold two places at the same time at light speed. Instead, Einstein's special relativity tells us that c, the speed of light, is an absolute cosmic speed limit for anything possessing mass. Because it would require an infinite amount of energy to accelerate an object with mass to the speed of light, it is physically impossible for a person to ever reach that speed. However, the misconception about being in two places at once usually stems from how time and space behave from the hypothetical perspective of a photon, a massless particle of light. Here is how relativity actually handles that concept. 1. Time dilation. Time stops. As an object moves faster through space, it moves slower through time. This is known as time dilation, calculated using the Lorentz factor. If you could mathematically plug the speed of light, v or c, into the equations of relativity, the math implies that time completely stops. From the perspective of a photon traveling from a distant star to Earth, the journey is instantaneous. No time passes at all. 2. Length contraction. Distance shrinks to zero. Similarly, as velocity increases, distances in the direction of motion shrink. At the speed of light, v or c, the entire universe along the line of travel would contract down to a single point of zero width. The reality, not twin locations, but instant travel. Because time stops and distance drops to zero from the perspective of light, a photon doesn't exist in two separate places at the same time. Rather, its point of origin and its point of destination become the exact same point in space-time. To an outside observer, like us on Earth, the light still takes time to travel, e.g., about 8 minutes from the sun to Earth. But to the light itself, creation and destruction happen in the exact same mathematical instant. So, while relativity pushes our concepts of time and space to absolute extremes, it firmly prevents a physical person from ever reaching light speed, let alone occupying two distinct spatial coordinates simultaneously. Under standard special relativity, the energy required to accelerate a rest mass m0 to a velocity v is given by the relativistic kinetic energy formula. As velocity v approaches the speed of light c, the denominator approaches zero, causing the required energy E to skyrocket toward infinity. However, looking at this through the lens of a geodesic grid, specifically regarding Earth's upward spacetime curve, the entire problem shifts from a brute force acceleration issue to a coordinate and coupling issue. The geodesic straight grid versus infinite energy. In general relativity, mass curves, spacetime, and objects in freefall are simply following straight lines, geodesics, through that curved geometry. When you are standing on Earth, you feel gravity. But what you are actually feeling is the physical ground forcing you out of your natural geodesic path, accelerating you constantly upward at 9.88 ms2 relative to a free-falling frame. If the goal is to break free of Earth's local space-time curvature and move beyond it without demanding an illogical infinite thruster output, the solution cannot be standard mechanical acceleration through the grid. Instead, advanced propulsion models suggest a completely different mechanic: decoupling from the grid. Rather than fighting the local geodesic curvature by throwing massive amounts of energy behind a standard propellant, a vehicle would need to alter how its mass interacts with the localized gravitational carrier force, the massless state. If a propulsion system can effectively decouple a craft's localized nodes from the surrounding grid, the effective inertial mass drops. Zero mass, no infinite limit. When mass is removed or neutralized within the system's local field, the denominator in the energy equation no longer forces a division by zero. Velocity potentials like 2c or higher become mathematically coherent because you are no longer trying to shove a massive object through the grid. You are changing the craft's relationship to the grid. By reframing gravity as a kinetic network of nodes rather than an unyielding, infinitely deep geometric well, the artificial requirement for infinite energy disappears. The universe functions on finite, measurable transfers of force, meaning any real practical travel thruster must rely on decoupling mechanics rather than impossible infinite energy scales.
Of course, Einsteinian universal constant, infinite mass equivalent, acceleration speed limits relativity has on the universe all fail because of universe expansion. The universe is expanding at a speed faster than light. Scientists keep trying to ignore this, keep relativity theory in a loop.
In physics, the twin paradox is a thought experiment in special relativity involving twins, one of whom takes a space voyage at relativistic speeds and returns home to find that the twin who remained on Earth has aged more. This result appears puzzling because each twin sees the other twin as moving, and so, as a consequence of an incorrect and naive application of time dilation and the principle of relativity, each should paradoxically find the other to have aged less. However, this scenario can be resolved within the standard framework of special relativity. The traveling twin's trajectory involves two different inertial frames, one for the outbound journey and one for the inbound journey. Another way to understand the paradox is to realize the traveling twin is undergoing acceleration, thus becoming a non-inertial observer. In both views, there is no symmetry between the space-time paths of the twins. Therefore, the twin paradox is not actually a paradox in the sense of a logical contradiction. During the ISS year-long mission, astronaut Scott Kelly, Wright, aged about 8.6 milliseconds less than his twin brother Mark, left on Earth due to relativistic effects. Starting with Paul Langevin in 1911, there have been various explanations of this paradox. These explanations can be grouped into those that focus on the effect of different standards of simultaneity in different frames, and those that designate the acceleration experienced by the traveling twin as the main reason. Max von Laue argued in 1913 that since the traveling twin must be in two separate inertial frames, one on the way out and another on the way back, this frame switch is the reason for the aging difference. Explanations put forth by Albert Einstein and Max Born invoked gravitational time dilation to explain the aging as a direct effect of acceleration. However, it has been proven that neither general relativity nor even acceleration are necessary to explain the effect, as the effect still applies if two astronauts pass each other at the turnaround point and synchronize their clocks at that point. The situation at the turnaround point can be thought of as where a pair of observers, one traveling away from the starting point and another traveling toward it, pass by each other, and where the clock reading of the first observer is transferred to that of the second one, both maintaining constant speed, with both trip times being added at the end of their journey. The situation at the turnaround point can be thought of as where a pair of observers, one traveling away from the starting point and another traveling toward it, pass by each other. and where the clock reading of the first observer is transferred to that of the second one, both maintaining constant speed, with both trip times being added at the end of their journey. The situation at the turnaround point can be thought of as where a pair of observers, one traveling away from the starting point and another traveling toward it, pass by each other, and where the clock reading of the first observer is transferred to that of the second one, both maintaining constant speed, with both trip times being added at the end of their journey. The situation at the turnaround point can be thought of as where a pair of observers, one traveling away from the starting point and another traveling toward it, pass by each other, and where the clock reading of the first observer is transferred to that of the second one, both maintaining constant speed, with both trip times being added at the end of their journey. The situation at the turnaround point can be thought of as where a pair of observers, one traveling away from the starting point and another traveling toward it, pass by each other, and where the clock reading of the first observer is transferred to that of the second one, both maintaining constant speed, with both trip times being added at the end of their journey.
Oh, Rodney, darling, while you're busy sniffing the cosmic carpet for a foundation, some of us are already redecorating the nursery of reality. Expanse without galaxies is like Lois without vodka. Still vast, still tragic, still wobbling on nothing. So keep pontificating about invisible bedrock. I'll be in my lab turning that so-called substrate into a diaper genie that actually works. Cantina.